So, hi guys, welcome back sa ating video discussion. So, for this video, we're going to discuss about soil compaction. Okay, in the construction of highway embankments, earth dams, and many other engineering structures, loose soils must be compacted to increase their unit weights. Compaction increases the strength characteristics of soils, which increase the bearing capacity of foundations constructed over them. Compaction also decreases the amount of undesirable settlement of structures and increases the stability of slopes of embankments. So during our previous discussions, we discussed that in a soil sample, we have the soil, we have water, and we have air. Water and air are voids. So yun yung gusto nating iwasan. Okay? So with soil compaction, we are trying to reduce the void in such a way that we are increasing the shear strength of the soil. Why do we need to increase the shear strength of the soil? We need to increase the shear strength of the soil so that we can increase the bearing capacity. So mas mataas yung kayang buhatin ng ating soil. Okay? And compaction also decreases the amount of undesirable settlement of structures and increases the stability of the slopes of embankment. Okay? So, like what we have discussed previously, pag meron niyang, pag hindi yan well compacted, pag hindi natin nabawasan yung void, there will come a time due to natural compaction, or yung tinatawag nating soil consolidation, magsisettle yung soil. Pag nabawasan yung volume ng soil, magkakaroon ng gap, and yung gap pwedeng mag-cause ng unwanted settlement. So, pwedeng masira yung stability ng ating structure. Okay? So, vibratory rollers are used mostly for the densification of granular soils. Vibrofloat devices are also used for compacting granular soil deposits to a considerable depth. Compaction of soil in this manner is known as vibroflotation. Okay? So, for this chapter, we're going to discuss more in depth, okay, yung soil compaction natin. By the way, this is chapter 6 from the book of Braha Emdas. Okay? So, compaction, in general, is the densification of soil by removal of air, which requires mechanical energy. So, we are going to densify our soil to remove, by removing the air. Pinabawasan natin yung void natin. Okay? And it is measured in terms of its dry unit weight. When water is added the soil during compaction, it acts as softening agent on soil particles. So the importance of adding water is to, it will help us determine the optimum unit weight of our soil. Okay? So nalalaman natin yon. Mamaya, i-discuss natin yan. Ito. So, the moisture content at which the maximum dry unit weight is attained is generally referred as the optimum moisture content. Kasi kung papansin niyo, pag umuulan, before umulan, ang soil, kunyari matagal na hindi umulan, mapapansin niyo na medyo loose. May tendency siya na maging loose due to load, no? Yung mga hindi na concrete. Then, or kaya yung mga disturbed soil, yung mga hinukay. Pero pag binasa nyo yan, if you're going to observe, parang nagkakaroon ng compaction. Okay? So, a certain amount of water will help in the compaction of the soil. Pero bakit natin sinabi ng optimum moisture content? Kasi may degree of saturation yan. Or may degree kung hanggang saan mo lang pwedeng lagyan ng water. Kasi pag na-reach na yung state na yon, maglo-loosen up ulit yung soil. Mawawala yung shear strength ng soil. Okay? So, in this graph, kung mapapansin nyo, habang nagdadagdag tayo ng water, so this is our water. Habang nagdadagdag tayo ng water, tumataas yung unit weight. Tumataas yung unit weight, but at a certain point, pag na-reach na yung maximum na level, or maximum level kung saan allowed optimum moisture content natin, bababa na siya. Ibig sabihin, pag tinuloy-tuloy mo yung pagdami ng tubig, malulus yung strength ng soil. Magdi-disintegrate siya. Okay? So, what are the tests? So, we have the standard Proctor test. In the Proctor test, the soil is compacted in a mold that has a volume of 944 cubic centimeter with a diameter of 101.6. The soil is mixed with varying amounts of water, then compacted 3 equal layers by a hammer with 25 blows each layer. The hammer has a mass of 2.5 kilograms and it has a drop of 3.5 millimeter. So therefore, the unit weight is equivalent to the weight divided by the volume of the mold. Okay? So makukuha natin. So ito yung ating apparatus. So ito yung apparatus natin. Hahatiin natin yan sa tatlong layer. Lalagyan natin ng soil at 1/3. Then, we are going to place this on top. Then, itataas natin itong hammer at bibitawan. So, magdadrop siya. So, gagawin natin yung 25 times. Then, lalagyan ulit ng soil dito. Ibabalik ulit to sa taas. Itataas itong hammer. Then, ibibitawan for 25 times. Next, i-attach itong extension. Lalagyan ulit ng soil. Then, papatong ulit yung hammer. Bibitawan ng 25 times. Then, from there, na-densify na natin yung ating soil. Okay? So, unfortunately, given our current condition, we will not be able to do this in the laboratory. Okay? So, sayang. Kasi it would be an exciting experiment. Laboratory experiment sana. But anyways, if you're curious on how it is done, maraming videos tayo sa YouTube. Okay? So, ito. So, habang dinadagdagan natin yung moisture content, yung water, dinadagdagan natin ng water, tumataas din yung moisture content. Like what I have explained a while ago. Then, pag na-reach na yung point, yung optimum moisture content niya, pag dinagdagan mo pa yan ng tubig, the shear strength will decrease, and at the same time, the dry unit weight will also decrease. Okay? So, we have here the saturation times the void ratio is equivalent to the specific gravity times the moisture content. So, the dry unit weight is equivalent to the specific gravity times the unit weight of water divided by 1 times the 1 plus the void ratio. Therefore, void ratio is equivalent to the specific gravity times the moisture content divided by the degree of saturation. Then, dry unit weight is equivalent to the specific gravity of the soil solid times the unit weight of water divided by 1 plus the specific gravity of soil solid times the unit weight of water over the degree of saturation. If we want the zero air void unit weight, ang saturation natin 100%. Ibig sabihin, pupunuin natin siya ng tubig. Saturated yung ating soil. Then we can get our zero air void curve. Okay? So this is a silty clay. This is a diagram for a type of silty clay. Okay? For a given moisture content, the theoretical maximum dry is obtained when no air is in the void spaces. That is, when the degree of saturation is 100. Sabi ko sa inyo kanina, to get the zero air void, dapat 100% yung saturation natin. So, yung S natin magiging 1. Okay? So, the unit weight of zero air void is equivalent to the specific gravity of the soil solids times the unit weight of water divided by 1 plus the moisture content times the specific gravity of soil solid is equivalent to the unit weight of water divided by the moisture content plus 1 divided by the specific unit weight of the soil solid. Okay, so how are we going to do that? Determine the specific gravity of the soil solids. Number 2, know the unit weight of water. Of course, we know that, 9.81 kilonewton per cubic meter. Assume several values such as 5, 10, 15%, and so on. Okay? Makikita naman natin di ba? Like here sa graph na to, 5, 10, 15. So, sa 15, nagkaroon na ng decrease. Then, sa 18, of course, malamang it will be a decrease. Then, yung mga points, ipagko-connect natin ng smooth curve. Then, yung maximum, project it horizontally, project it vertically. Then, makukuha natin yung maximum dry unit weight, makukuha natin yung optimum moisture content. So, the soil type, the grain size distribution, shape of soil grains, specific gravity of soil solids, and amount and type of clay minerals present. This factors has great influence on the maximum dry unit weight and optimum moisture content. Okay, so these are outputs of some laboratory tests that were conducted with respect to ASTM designation D698. So, silty sandy silt, so more or less ganito ang itsura ng curve. So, silty clay, ganito ang itsura ng curve. We have high plastic clay. Ito naman itsura ng curve natin. Then, we have a poorly graded sand. So, for a poorly graded sand, of course, we can expect na yung if we're going to densify that, medyo hindi ganun kataas yung makukuha natin because it is granular in terms of shape. In terms of shape kasi medyo angular yung shape ng sand. So, maraming voids talaga dyan. Okay? So, we have here the bell shape type. We have 1.5 peak. We have the double peak, so dalawang beses siya nag-peak. Then we had the odd shape. So, the liquid limit for this type of curve, ito yung mga yon. 30 to 70, less than 30, less than 30, and those greater than 70. So, ito yung less than 30, greater than 70. Then, the odd shape, which is greater than 70 for the liquid limit. Okay? So, effect of compaction effort. So, the compaction energy per unit volume used for the standard Proctor test described in section 6.3 can be given as number of blows. Kung ilang beses siyang hinulog, which is 25. Tama? Then, number of layers, we have 3. Weight of the hammer. Anong weight ng hammer natin? We have 2.5 kilogram or 5.5 pounds. Height of draft of the hammer, we have 304.8 mm or 12 inch. Then, the volume of the mold, actually standard na tong mga to, no? It's already given. The diameter is 101.6 mm or 4 inch squared. Therefore, it will give us 944 mm cube. Okay? So, it is equivalent to 694 kilonewton meter per cubic meter. Yan yung energy natin for the test. Okay? Or it is almost equal to 600 kilonewton meter per cubic meter. Okay? If the compaction effort per unit volume of soil is changed, the moisture unit weight also changes. This fact can be demonstrated with the aid of figure 6.6, which shows 4 compaction curves for a sandy clay. The standard Proctor mold hammer were obtained using the compaction curves. So dito ang ginawa, nagkaroon tayo ng we tried different numbers of blows. So, it is between 20 to 50. So, kung titignan mo, 20 blows lang, yung first, yung layer mo, per layer, 20 blows lang, ang maximum na pwede mong makuha na unit weight is nandito lang. Nag-increase, ginawang 25, tumaas. It is at this level. Nag-increase from 25 blows, it became 30 blows. Then, it increases. Then, it became 50 blows per layer. So, therefore, if there is an increase, there is a change. Yeah. If there is a change in the effort for compaction, the moisture, the unit weight also changes. Nag-change yan. So this is our zero air void curve. So you have here the saturation, which should be equal to 100. Okay? So empirical relationships. Omar et al. Presented the results of modified Proctor compaction tests on 311 soil samples. Of these 45 samples, gravelly soil, 246 were sandy soil, 2 were clay with low plasticity. All compaction tests were conducted using ASTM 1557, method C, to avoid oversized correction. Based on the tests, the following correlation. So we will be using this formula later. We will be using this formula and i-explain naman. I-state naman doon kung we're going to use this or hindi. Okay, sa problem. So, since your home activity is be given at home, so hindi ko na kailangang sabihin open notes. So, yeah. It is indirectly implied. Okay? So, the dry density maximum kilogram per cubic meter is equivalent to 4,804,574 times the specific gravity minus 195.55 times the liquid limit squared plus 156,971 R number 4 raised to 0.5 minus 9,527,830 raised to quantity raised to 0.5. Ln for the optimum moisture content, 1.195 times 10 raised to negative 4 times the liquid limit squared minus 1.964 times the specific gravity minus 6.617 times 10 raised to negative 5 times R number 4 plus 7.651. So, R number 4 is the percent retained sa number 4 sieve. So, more or less, these are the number of gravel. Okay? So, ito yung sa standard Proctor hammer, modified Proctor hammer. Then, sa right side, we have, this is the standard sa left. Sa right is the modified Proctor hammer. Okay? So, we have here a comparison for standard Proctor test and for the modified Proctor test. So, for the standard Proctor test, we are given here our values for method A, method B, method C. Method A, ang data na kailangan natin, use 20% or less by weight material retained on number 4, and so on. So, we have their method B, passing 9.5 mm sieve, used if more than 20% of the weight of material is retained on number 4, or 20 or less than weight material is retained on 9.5 mm sieve. So in between. Method C, passing 19 mm sieve, used if more than 20% by the weight of material is retained on 9.5 mm seed and less than 30% by the weight of material is retained on 19% mm sieve. So, dito, magkakaiba din yung number of blows for method A, 25, method B, that is 25, method C, that is 56. Okay? So, for granular soils with less than 12% fines, or mas fine pa sa number 200 sieve, the density may be a better indicator for end product compaction specification in the field based on laboratory compaction tests on 55 clean sands, less than 5% finer than number 200, provided the following relationship. The relative density is equivalent to A times D raised to negative B sub 50. A is equivalent to 0.216 ln of E minus 0.85. B is negative 0.03 ln of E plus 0.306. D is the median grain size. Okay. Gertug and Sridharan propose correlations for optimum moisture content and maximum dry unit weight with plastic limit of cohesion. So, ito naman yung kanilang naging equation. Okay. For modified Proctor test, E is 2,700 kilonewton per cubic meter. Therefore, the optimum moisture content is 0.65, approximately 0.65 times the plastic limit. And this is your maximum dry unit weight. Then Osman et al. In 2008 analyzed a number of laboratory compaction test results of fine-grained cohesive soils, including those provided by Gurtug and Sridharan in 2004. Based on his study, the following correlations were developed. So for the optimum moisture content, ito yung formula. For the dry unit weight, maximum, ito naman. Okay? And Mateo et al. In 2009 analyzed the result of 71 fine-grained soils, okay, and provided the following correlations for optimum water content and maximum dry unit weight for modified Proctor test. So, ito naman yung kanilang output. So, if you think that geotechnical engineering is just a small part of the civil engineering field, dito pa lang makikita nyo pa lang sa soil testing pa lang, you're wrong. Okay, it is a much broader pa. So if ever you finish your degree, I think it is better if you're going to consider geotechnical engineering. Geotechnical engineering, waters engineering, tsaka transportation engineering are the less path taken by common civil engineering graduates. Okay. So for this is the part 1 of the soil compaction video lecture. So stay tuned for video part